Assalamualaikum and good evening. So for our case study topic is pallet rack collapse. Next, meet our members. The first is Wafa, and next is Madiha, and Shafika, Moment, and Madrujo. For our case study is about a company using a steel rack system to store their materials in their factory. So this system consists of 4 parallel columns, tie beam, and also square base plate. So there are about 6 pallets for each level of plate, which the maximum weight is about 10,000 Newton. And after a few weeks use the rack, the system is suddenly collapsed. So we as a consultant company are appointed to solve this problem. Next, this diagram is show the direction of the load transfer from the pallet, and then it goes to the tie beam, and next it go to the column, and lastly it go to the base plate. So this is the same thing is happen for each level of pallet. Next, we need to draw the bending moment by using a moment distribution method. So this is example of one level of the pallet. So the first step is we need to identify the member and joint stiffness. After we get the member and joint stiffness, we need to calculate the distribution factor for each joint. Then we need to calculate the carryover factor and fixed end moment. And the value for fixed end moment only have at the member BC, which is 1.75 kN per meter. After we got all the elements, we need to calculate the end moment by using distribution table. So for the end moment for member AB, the value is 0.548, for BA 1.149, for BC negative 1.149, for CB 1.149, for CD negative 1.149, and for DC is negative 0.548. After we get the end moment, we need to calculate the reaction force for RA and RD. So the value for reaction force for RA and RD is a 5 kilonewton. After we already got the reaction force, we can draw the shear force diagram and bending moment diagram.
Hello and Assalamu alaikum. My name is Madhu and I'm a fellow member of this group, and I'm going to discuss about question 3 on 3 hypotheses of why the structure might have failed. So case number 1 is very obvious, which is the overloading of the track. We all know that the rack has a specific load bearing capacity, and if the maximum load is exceeding, it will definitely fail. There would be buckling, there would be deflection, which will eventually cause to the failure of the structure. Another reason could be that there was an external load acting on the track. So the track is suppose empty and it's stationary, but there is a lift truck that will fall from a specific height, which will cause the collapse of the structure. In question number 4, we have showed an example of that as well, that from a height of 1.4 meter, if a lift truck is dropped, so it will collapse. Case number 2 discusses about the maximum unsupported span, which was inadequate in our case. So the vertical beam spacing plays a huge role in the weight bearing capacity. When designing a pallet, it should be kept in mind that the maximum unsupported span, which is the height between one beam to another beam, needs to be studied to establish load bearing capacity. Here in this hypothesis, it is believed that the unsupported span length was like too high or excessive. This is why there was a beam deflection causing a failure. Case number 3, we assume that there was some flexural buckling. Here we assume that the slenderness of the bracing was too thin, causing it to limit its strength compared to the length which was exceeded. Steel members having symmetric, closed or double symmetric cross sections mostly experience flexural buckling. Buckling happens when a member's unbraced length exceeds its stiffness ratio. Flexural buckling causes a straight part to become bow-shaped. Buckled members may lose their load-carrying capacity and fail under high compressive loads.
In our modular rack system, we have conducted a thorough stability analysis that meticulously takes into account the integration of base plates and bracing elements, stiffness, and their impact on the critical buckling load. Our examination also delved into the effect of determining cyclic moment rotation on both the global stability of the frame and the established stability limit. Specifically, the latter is defined concerning the accommodation of a maximum pallet load on the designated rack system. Furthermore, our study addressed the minimum track load capable of causing the collapse of the rack system when subjected to impact from a lift truck at a height of 1.4 meter. It is crucial to note that these calculations are simplified and approximate, omitting consideration for various factors such as dynamic effect, material properties, geometric imperfections, and connection details. Therefore, the result should not be considered reliable or accurate due to the inherent limitation of this simplified approach. Our investigation into the minimum track load involved applying the load horizontally at the midpoint of an empty rack system column, situated at a height of 1.4 meter. A bending moment is then introduced to the column. It's important to note that the column is fixed at the base, free at the top, and has a length of 9.8 meter, with a cross-sectional area of 120 times 120 millimeter and a thickness of 2.5 millimeter. To determine the minimum track load that could lead to system collapse, we consider the yield strength of the steel, which is 280 megapascal, and the modulus of elasticity set at 200 gigapascal. Our approach involves a comprehensive analysis that takes into account the system structural characteristics.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mu'min Muhammad Al Abdurrahman, and now I will explain question 4 calculation step by step. After our teammate Madiha explained us about the topic or what the question talking about and the introduction of the questions. Now, the potential failures point is such as the connections, the tie beams, and the columns, and the base plates, and the critical bulking of the columns by Euler formula. Where in the right side here, we're gonna use PCR equal pi power 2 EL divided by KL power 2. This the Euler formula talking about the main formula. Now, for references, E will be E the modulus of elasticity, and I second moment of area, and K the effective length of factor, and L here length of the column. Now, as we are after reference for our formula, the PCR equal pi power 2 multiply 200 multiply 10 power 9 multiply 2.64 multiply 10 power 2 divided by 0.5 multiply 9800 power 2. After calculating all the result will be PCR equal 1.366 multiply 10 power 18 Newton. As we write here, the coordinates accorded along to the moment frame axis A and B axis the model in as we can see in the area. And for a next step, we going to calculate the second moment of area of the column. Our reference here will back to I. This is the main formula to calculate the second moment. Here I equal BH multiply 2 multiply 3 divide by 12 minus B minus T H minus T power 3 divide by 12. And after the calculating, and as here 220 multiply 120 power 3 divide 12, and after calculating the result will be 1.3956 multiply 10 power 6 Newton. And this is for the result about the second moment of area of the column. For the second moment area, the column has been evaluated the B and the base width and H, and this is the information we give it to you in the right side. And after that, for a next step, we going to calculate the bending moment of the column, and reference here for the formula in the right side. After calculating, we're gonna use two formula, my divide I and PCRL divide by 2, and where is here m equal the bending moment, and y is the distance from the neutral axis, and I is the second moment of area, as we said again. And after saying all that, the result will be 6.83 multiply 10 power 2 Newton per millimeters. And the bending moment of the column and the bending stress moment of the column has been calculated already from here. And for a last step, the column will be collapse when the bending stress exceed the yield stress of the steel. And here the last step we're gonna explain here the minimum track load that can cause the bending stress to the equal yield stress area. Now we're gonna use the formula in the right side. B minimum to gamma L divided by Y L. And here, after give the values and the calculating all this, the P minimum will be equal to 25,333.33, and the minimum track flow that can lead to the collapse of the rack system when hit by a lift track, and 1.4 meters height is the approximately, and the result is, or the result of the question will be 253.3 kilonewton. This is a simplified of estimating, not to consider two important factors. And we're gonna move to next part. And this is my explain about the calculation of question 4. And thank you very much.
Thank you. Now I'll be in charge for the recommendation to avoid failure of rack system for frame for the future. First is to implement load monitoring system. It is to install load monitoring system that provide real-time information on weight distribution. This can be helped to ensure the rack system is not overloaded, preventing stress on the components. After that is regular training and awareness program. It is to conduct regular training in programs for personnel to educate them on proper loading practices, weight limits, and importance of adhering to safety guidelines. This can be created a culture of awareness to prevent misuse. After that is environmental control. Control the storage environment by implementing measures such as climate control, corrosion resistant coating, and proper ventilation. Protecting the rack system from extreme temperatures and corrosive substances can extend its lifespan. After that is the periodic structure assessment. This can be conduct the periodic structure assessment of the rack system involving professional engineers such as us if it's necessary. Can be helped to identify potential weaknesses or stress points and address them before they can lead to failures. In a nutshell, the structure integrity of the rack system under specified condition, it is evidence that the system is subjected to a horizontal load at the midpoint of a fixed column with no pallet load. The structural properties of the column, including its length, cross-sectional area, thickness, and the materials, viewing strength, and modulus of electricity plays a crucial role in determining its stability. The fit base and the free top configuration of the column combines with the applied horizontal load and bending moment creates a condition that demands careful consideration of potential failure points. With a yield strength of 280 megapascal and a modulus electricity of 200 gigapascal, the steel material exhibits strength and stiffness that need to be effectively managed to avoid structural issues. Preventing failures in the rack system requires a multifaceted approach. Implementing load monitoring system, regular training, and essential maintenance protocol address issues related to the overloading misuse and maintenance neglects. Meanwhile, environment control contributes to the system resilience against external factors. Combining this prevention solution fosters a safer and more robust storage environment, minimizing the risk of the rack system failures. Thank you.